Hi everyone, my name is Claire Gan. I will be presenting a paper called JASGPT Speech Gesture Synthesis with Text Parsing from ChatGPT. So firstly, I want to start off with some introduction of the papers. This paper focuses on gesture synthesis, which is a research field that aims to create natural and contextually appropriate gesture that corresponds to given speed and textual inputs. Asking a significant attention as a critical research field, where a majority of the existing method has adopt deep learning-based approach, which is primarily focused on the audio features extract from the speech signals to model and generate gestures. However, there are certain drawbacks to personal approach that overlook the rich semantic information, include textual input. Also, they may fail to address the fundamental intention in gesture expressions. So the objective of this paper is creating a model called JustGPT, where it's a novel approach to gesture generation that leverage the semantic analysis capabilities of a large language models. By capitalizing on the strengths of large language model of text analysis, the author has adopted a controlled approach to generate and integrate professional gesture and base gestures through a text processing script. The results demonstrate that JustGPT effectively generate contextually appropriate and expressive gestures. For some literature review of this paper, in the field of psychology, researchers have discovered that speech and gesture can enhance each other comprehension where they convey information that is semantically consistent. Various deep learning approaches have been combined with rule-based methods to produce more natural and semantically rich gestures. In Sachs' paper, they explore the use of gesture semantic classifier to attain semantic labels for the gesture and ensure that coherency in the generated semantics. In Manel's work, they explore how gesture and language work together in a dialectic. In this analysis, the purpose of gesture is to fuel and propel thoughts and speech. In the motion GPT models, they propose a unified emotion language model, which is pre-trained based on the emotion vocabulary. Their approach demonstrates promising results in various tests, including motion predictions. In this paper, the authors refers Manel's classification of gesture functions to classify text into multiple intents and utilize text parsing script derived from ChatGPT to generate expressive gesture with communication functionalities. So here's the overall framework of their models. This includes three modules. The first module is text parsing modules that leverage large language model such as ChatGPT. The second module is the professional gesture lexicon module with semantic annotation. The last module includes the gesture integration module based on the text parsing results. For the text parsing results, their their goal is to assign contextually appropriate gesture to each sentence in the text. Their first process one sentence at a time and divide it into three subtexts, such as determining the intention expressed in the sentence, identifying the words that require emphasis on the sentence, and recognizing the words that carry the semantic significance in the sentence. To design a specific prompt of the three objectives, we're expressing intention defined as a classification text, emphasizing words and semantic words defined as a recognition test. After that, they have leveraging ChatGPT and analyze the deep semantic information enabled within the sentence. Moving to the next modules. After following the parsing of the text, the predefined search rules are employed to match the corresponding professional gesture from the gesture lexicons. The ChatGPT model The JAST-GPT model generates a gesture within the complete state and professionalism. They primarily extract gesture clips from the Beats and Drupal datasets obtained from internet videos. In order to enhance the functionality of the gesture lexicons, they apply text parsing methods to annotate each gesture's units with its corresponding action intentions and semantic words based on the company text. Moving onto the last modules, which is JAX integration. When the gesture integration module, the diverse gesture are integrated based on the parsing scripts. The frameworks allow the control the generation of meaningful and visually comprehensive gesture in accordance with the text parsing scripts. This module combines the semantically professional gestures from the gesture lexicons with the base gesture as well. To to experience and test with their model, they use two study. The first is the user study where they use the beat and Drupal video and users were assigned to evaluate gesture videos of ground truth, baseline, and JAST-GPTs. They gather feedback from 50 users for the Beats dataset and 35 users for the Drupal datasets. As the result shows in the table, that JAST-GPT have performed superiorly across all three alphabets from both models. The second experience data is the visualization results. It illustrates the effectiveness of both methods in generating gesture of complete sentence. The green semantic represents the position where the emphasized words appear in the parsed scripts. It's evident that JAST-GPT is capable to generating more diverse and comprehensive gesture, where the baseline models generates the result are more relatively narrow compared to the JAST-GPTs. In conclusion, this JAST-GPT were able to propose a new gesture generation based on large language models and they're able to use ChatGPT for text parsing to attain the textual intent, emphasize words and semantic words, and form a parsing script. Subsequently, they're able to generate and fuse gesture based on the parsing script, leveraging and constructed annotated gesture lexicons. All those experimental results on the Beats and Drupal datasets demonstrate that their method can generate a natural and expressly rich gestures. There are certain drawbacks for this paper where during the text processing, the authors were assumed that each sentence contained exactly one intent. This may limit the capacity to communicate several intents in a lengthier text or without particular intents. They may also consider more contextual information than a single sentence during a text processing, which will enhance the processing efficiency. And lastly, here